Hello, chemistry students.
Hello.
My name is Bond. Covalent Bond. What's your name?
My name is Bond. Ionic
Ionic Bond. Oh, hey, Josh. My name is Justin Shin. This is
Joshua Lee.
and Josh. I think this is our 15th podcast now.
Yeah,
15. Yeah,
exactly.
yeah. So we're doing well. We're. What are we doing today? What are we doing today,
We're doing
Josh?
solubility equilibrium.
Solubility equilibrium.
Yeah.
Equilibrium.
Mm-hmm.
Equilibrium.
Mm-hmm.
The equilibrium. Okay, well, chemistry students, equilibrium is one of the, the little harder units that you're going to be experiencing throughout the year. But we'll we'll show you a way to get through solubility equilibrium right now, right?
Yeah,
Right,
you
Josh?
can do it.
Yeah, we can do it. So, what's the problem today?
So a solution is prepared by mixing 150 milliliters of 10 to the negative 2 molarity MgNO32 and 250 milliliters of 1.0 times 10 to the negative 1 molarities of NaF. Calculate the concentrations of Mg and F at equilibria with solid MgF2. KSP is 6.4 times 10 to the negative 9.
Hey, Josh, I want to. What is solubility? Just for the people that don't know about.
Solubility is the ability of a solute to be dissolved inside a solvent.
So, solute in a solvent, right?
Yeah.
Solute to a solvent. Okay, perfect.
Beautiful.
Beautiful. Okay, Josh, quick quiz. What do we always start off with in this equation? What do we need right here?
We need a net ionic equation.
Exactly, net ionic equation. And so here we can see that this is sodium fluoride. Anyways, we have magnesium and we have fluoride, right?
Yeah.
So we have MgF2. So we can start off by going, we start off with our compound MgF2, right?
Yep.
And what does that dissociate into? You know?
Whoa. Mg2 plus and F minus.
All right, sweet. Now we're gonna move on.
Hold up, man.
What's going on?
Did we balance the charges right?
Oh, we didn't balance the charges right. And in fact, we have two fluorines over here. Yeah, we only have one. So we gotta put that magical 2.
Yeah, now I feel better.
Okay. That's good catch. Okay, so what do we start off doing first? We have these. We have the milliliters, and we have the molarity over here.
Well, since we're dealing with liters and molarity, why don't we just set up a Brita?
A Brita. Oh, a Brita. So we have a Brita table. We have molarity.
Oh,
Whoa. Then it
moles?
moles.
No, yeah.
No.
Yeah.
Okay, forget Brita table. We multiply we make 150 milliliters into liters. So it's going to be 0.150 liters, right?
Yeah.
Times the molarity. 0.00 times. Are you punching that in your calculator?
Oh, yeah, as we speak it right now.
And
And we are getting 0. Wait. 0.625. There. 0.0625.
Isn't it 1.5?
Oh, yeah.
Yeah, it's 0.0015 moles.
Oh.
Yeah, and then okay, and now we're going to be solving for the moles of sodium fluoride, right? 0.250 liters times.
Alright, so now that we have the moles, we gotta divide it by the total number of liters that we have in the solution, which is 0.0 liters.
Which is 0.4 liters.
Uh-huh. And that leads us to 0.00375 molarity of that Mg2 plus, and with this 0.0625 molarity of F minus. Alright, so now that we have this situation going on, and then we will just take the net ionic equation and find the molarities that we have.
So what he means by net, what we're basically doing now is just solving for the KSP value, right? Or
Exactly.
the QSP value, right?
Exactly.
So the QSP value is more of a, it's the solubility in this instance, in this reaction, right?
Yeah.
Not just the typical. Zoom in a little.
Oh yeah.
Little technical difficulty. Ooh, just a little too much. Oh, there we go. Awesome. Okay, scroll up just a little so everyone can see that. All right. Scroll a little downwards. There we go. There we go. There we go. Okay, now since we have that, we
just let me do this.
Come on, Mr. Ionic Bond. Okay, there we go.
All right.
Now since we're here, what we're gonna do is put this as the QSP. Excuse me. So this is the
So what is
MG.
QSP?
It's the constant.
Yep, it's always products over reactants.
In this case, we just have
products because the reactants is going to be a solid, so we never include a solid in a QSP or KSP.
And don't forget to raise it up to the 2, the coefficient.
Exactly.
And so we're just going to plug these values straight in the equation. 0.75, and you should get a 0.0625 squared, and you get a beautiful number of 1.5 times. Oh, is there something wrong with this?
Oh, look at that. Sig figs.
You had a kind of little response time, huh? For that. 10 to the -5.
Time.
Okay. So now what we're going to see from this precipitate reaction is to see whether or not the QSP value is larger than the original KSP.
Exactly. And so what Mr. Ozuna always told us was that we'd always put it in alphabetical order, which means it goes K to Q.
Oh, really? So it would be 6.4 times 10 to the -9 is the KSP. And then here's a QSP.
Yep. And so that is...
You can officially say that the QSP is larger, meaning that a precipitate will form. Okay, and with that, let's scroll down a little here. Alright, now since we know the precipitate is going to form, aren't we going to write the equation in a certain way?
Oh, now we got to flip it.
Oh, we got to flip the equation from 2F minus, excuse my handwriting, to MgF2. Awesome.
Okay, so now that we have this net ionic equation, we just need to put down the moles of what we have to find the limiting reactant. So how many moles of fluorine did we have? Let's check on that.
We had 0.025 moles. And we have 0.0015 moles here.
Easy. So which one is the limiting reactant?
Do you hear that? That ice cream man? Yeah. Anyways, okay. 0.015 moles right there. And so now, what are we going to be doing, Josh?
Oh, we found a limiting reactant, so we just subtract magnesium by 0.0015, eliminating that because that magnesium is going to get completely used up during the reaction, and we're going to subtract 2 times 0.0015 moles from fluorine because fluorine has a 2 to 1 mole ratio with magnesium. So from 0.025 we subtract by 0.003.
Alright.
Alright.
115. You're going to want to multiply this by 2.
Yeah.
That equals 0.022 mole. Moles are always lowercase. And we got that. And now we divide that by the total volume, right? 0.4.
Yeah.
Liters. That equals 0.055 concentration of fluorine, right?
Oh, there's one thing wrong though. What was the sig figs given in the problem?
Sig figs given in the problem
Lowest one was
3. 4. 4. 3.
3.
3. 3. Yeah. 3.
So we just add a little 0.
Yes. Let me run this way here. 5, 0. There we are. There's a molarity for F minus, or is it F minus? F minus.
Okay, let's see. So now we just got to get the magnesium from the problem, right? So this is where KSP comes into play, right? So the KSP given was 6.4 times 10 to the negative 9.
9.
And so, what was the equation that we used earlier for Q?
Right here. Right here.
Yeah. So now, since we have established equilibrium, we can use a KSP value. So K is gonna. I'm just gonna open this up a little bit.
Yeah. Oh. Okay. Zoom back in. K value. Here, I got it. Right here. K value, which we already know as a value of 6.4 times 10 to the negative 9. Negative 9. We do that, and we have Mg, 2 plus concentration here, and we have fluorine concentration right there, squared.
Beautiful.
So then we just plug in the fluorine concentration right here, and then we solve for this missing value, and we'll label that as X. So it would primarily be like and we label that as X, and then we put this value straight in by going 0.0550 squared equals 6.4 times 10 to the negative 9, and we get an X value, or concentration of magnesium 2 plus, as
2.0 times 10 to the negative
6. And so two sig figs.
All right, guys, that was
Yeah,
fun.
and that was our last podcast. And we yeah,
Good luck on the AP test.
yeah. Good luck, guys.
Bye.